Good afternoon, everyone. I am Renica K. Torres,
And I'm Mariana Fuentes.
and we are here to talk about lean operations. As business organizations strive to maintain competitiveness in an ever-changing global economy, they are increasingly seeking new and better ways of operating. For some, this means changing from traditional ways of operating to what is now referred to as lean operation. As a start, we must first know the meaning of lean operation. Lean operation is a flexible system of operation that uses considerably fewer resources than a traditional system. Furthermore, it tends to achieve greater productivity, lower cost, shorter cycle times, and higher quality than a non-lean system. It is sometimes referred to as just-in-time system, which are highly coordinated processing system in which goods move through the system and services are performed just they are needed. Lean operation was pioneered by Toyota's founder Taiichi Ohno and Shigeru Yoshino. The development in Japan was influenced by the limited resources available at that time. Not surprisingly, the Japanese were very sensitive to waste and inefficiency. Toyota's focus was on the elimination of all waste from every aspect of the process. Following its success, today the lean approach is being applied in a wide range of manufacturing and service operations. Many of the methods that are common to lean operation were developed as part of the Japanese car maker Toyota's approach to manufacturing. You can get a sense of that approach from some of the terms commonly associated with lean operation. The first one is muda, which is all about waste and inefficiency. Another term is called Kanban. It is a manual system that signals the need for parts or materials. This applies both to delivery to the factory and delivery to each workstation. Pull system refers to the replacement of materials or parts based on demand, producing only what is needed. Another term is heijunka, means that variation in production volume lead to waste. The workload must be leveled, volume and variety must be averaged to achieve a steady flow of work. Next is kaizen, is the continuous improvement of the system. Since there is always room for improvement, this effort must be ongoing. Judoka is a quality at the source. The source here is the worker. Each worker is expected to perform ongoing quality assurance. The objective here is to avoid passing defective products to the following station and to make workers aware of the quality. Pokayuk are safeguards built into a process to reduce the possibility of errors. Last one is the team concept, which uses small teams of workers for process improvement. A widely held view of the just-in-time or lean operation is that it is simply a system for scheduling production that results in low levels of work in process and inventory. The philosophy of this is to produce a system that functions well with minimal levels of inventories, minimal waste, minimal space, and minimal transactions. The ultimate goal of a lean operation is to achieve a system that matches supply to customer demand.
There are three supporting goals making up the lean. But the ultimate goal of it is a balanced system, one that achieves a smooth, rapid flow of materials and are worked through the system. The idea is to make the process time as short as possible by using resources in the best possible way. The first supporting goal is to eliminate disruptions. Disruptions have a negative influence in the system by upsetting the smooth flow of products through the system, such as poor quality, equipment breakdown, changes to schedule and late deliveries. All disruptions should be eliminated where possible. This will reduce the uncertainty that the system must deal with. The second one is making the system flexible. A flexible system is one that is robust enough to handle a mix of products and to handle changes in the level of output while still maintaining balance and throughout speed. Long setup times and long lead times negatively impact the flexibility of the system. Hence, reduction of setup and lead times is very important in a lean system. Last one is to eliminate waste, especially excess inventory. Waste represents unproductive resources. By eliminating waste, it can free up resources and enhance production. Also, inventory is an idle resource taking up space and adding cost to the system. It should be minimized as much as possible. In the Lean philosophy, there are 7 wastes, namely inventory, which takes up floor space and adds to cost; overproduction, which involves excessive use of manufacturing resources; waiting time, which requires space and adds no value; unnecessary transporting, which increases handling, increases work in process inventory; inefficient work methods, which reduce productivity, increase scrap, increase work in process inventory; and lastly, product defects, which require rework costs and possible lost sales due to customer dissatisfaction.
The design and operation of a lean system provide the foundation for accomplishing the aforementioned goals. The building blocks are product design, process design, personnel and organizational elements, and manufacturing planning and control. Speed and simplicity are two common threads that run through these building blocks. The first building block to be discussed is a product design. There are 4 elements of product design that are important for a lean production system. These elements are standard parts, modular design, highly capable production system with quality built-in, and concurrent engineering. The first 2 elements relate to speed and simplicity. The use of a standard part means that workers have fewer parts to deal with, and, and training times and costs are reduced. Purchasing, handling, and checking quality are more routine and lend themselves to continual improvement. Modular design is an extension of standard parts. Modules are clusters of parts threaded as a single unit. This greatly reduces the number of parts to deal with, simplifying assembly, purchasing, handling, training, and so on. Highly capable production systems are required by lean. Quality is the main ingredient of the lean system. It is crucial to the lean system because poor quality can create major disruptions. Quality must be embedded in goods and processes. For example, because of small lot sizes and the absence of buffer stock, production must cease when problems occur, and it cannot resume until the problems have been resolved. Obviously, shutting down an entire process is costly and cuts into planned output levels. So it becomes imperative to try to avoid shutdowns and to quickly resolve problems when they do appear. The last one is the concurrent engineering. Engineering changes can be very disruptive to smooth operation. Concurrent engineering practices can substantially reduce these disruptions. It is a method by which several teams within an organization work simultaneously develop new products and systems. For example, in many highly technology areas such as electronics and telecommunications, product technology performance is continuously increasing and price levels are dropping almost daily. In such areas, a firm's ability to sustain its competitive edge largely depends on the timely introduction of new or improved products and technologies. More and more, the time parameter makes the difference between mere survival and substantial profit generation. Concurrent engineering is a key method for meeting this need for shortening or a new product time to market.
The next building block is called process design. 8 aspects of process design are particularly important for lean production systems: small lot sizes, setup time reduction, manufacturing cells, quality improvement, production flexibility, a balanced system, little inventory storage, and fail-safe methods. In the lean philosophy, small lot sizes are very important. The ideal lot size is 1 unit, a quantity that may not always be realistic owing to practical considerations, requiring minimum lot sizes. The goal is still to reduce the lot size as much as possible. Small lots also permit greater flexibility in scheduling. In traditional systems, this usually means long production runs of each production, one after the other. Although this spreads the setup cost for a run over many items, it also results in long cycles over the entire range of products. For example, suppose a firm has three product versions, A, B, and C. In a traditional system, there would be long run of version A, and then a long run of version B, followed by a long run of version C before the sequence would repeat. In contrast, a lean system using small lots would frequently shift from producing A to producing B and C. This flexibility enables lean system to respond more quickly to changing customer demands for output. Lean systems can produce just what is needed when it is needed. Setup time reduction is the second one. Small lots and changing product mixes require frequent setups. Unless they are quick and relatively inexpensive, the time and cost to accomplish them can be prohibitive. Moreover, long setup times require holding more inventories more than with short setup times. Strong emphasis on reducing setup times is implied. Shigeo Shingo made a very significant contribution to lean operation with the development of what is called the Single Minute Exchange of Die (SMED) system for reducing changeover time. The potential benefits that can be achieved using the SMED system were impressively illustrated in 1982